question says use 4 cross 1 mux to implement 8 cross 1 and 16 cross 1 mux. Let's say first 16 cross 1. So the first step is to find number of 8 cross 1 mux required to generate 16 cross 1 mux. Okay, so 16 cross 1, sorry, we are using 4 cross 1 mux. So 16 by 4, it gives 4, which is again divided by 4 to get 1. Now since we have finally got 1, no further division required. Therefore, total number of 4 plus 1, 5 4 cross 1 mux required to implement 16 cross 1 mux. Similarly, to construct 8 cross 1 mux, we can find cross 1 divided by 4, that is 4 divided by 2. Now since this is not 1 and we cannot also further divide this by 1, we take 2 divided by 4 as 1. Therefore, total of 2 4 cross 1 mux required plus, and since this 1 is a normal 1, we take it as 1 a lower order mux, that is 2 cross 1 mux is required in this case. Therefore, the construction for this will be like this. This is level 1, this is level 2. So this will be 0, 1, 2, 3. This will be again 4 inputs, 1 output, and since we require one number of 2 cross 1, so these are two number of 4 cross 1 mux, and this is one number of 2 cross 1 mux to implement 8 cross 1 mux. Now let's study the application of mux, how the mux can be used to implement the logic gates. Let's study first the implementation of 2 input logic gate using 4 cross 1 mux. Implement 2 input logic gates using 4 cross 1 mux. Now here we have A and B as a select lines. Okay, let's take A, B, input 0, 0, 0, 1, 1, 0, 1, 1. Fill with output. So since we have to implement a 2 input logic gate, let's take the XOR logic gate. That is, we will implement a 4 cross 1 mux. We will use 4 cross 1 mux to implement an XOR gate, that is A plus B, where A and B are select lines. So the truth table of XOR gate shows 0 XOR 0 is 0, 0 XOR 1 is 1, 1 XOR 0 is 1, 1 XOR 1 is 0. Therefore, we can directly write down from the figure as A, B select lines. Okay, 4 cross 1 mux, therefore 4 input, 1 output. If A and B are 0, we take this as 0. If A is 0, B is 1, we write it here down by 1. If A is 1, B is 0, our selected line should again be 1. That is, line number 2 is selected. This is line number 0, line number 1, line number 2, line number 3. And when 1, 1, that is line number 3 is selected, the input should be 0. This is the output. For better understanding, let's take an example of how the output Y can be selected. The circuit diagram for which is as follows. So let's find out what will be the output Y. Let's take different values of A, that A and B, it is 0, 0, 0, 1, 1 0 1 1. Okay, if A and B are 0, Y will be A bar B bar C. That is line number 0, line number 1, line number 2, line number 3. Line number 0 is selected. A bar B bar C plus A bar B, again 1 will be selected, so it will be A bar B C plus, if this is output, input 1 0, that is 2, line number 2 gets selected, which is A B bar C bar C bar plus A B C bar. So if we try to sort this out, let's say we try to sort it out by taking this as common, A bar and C as common. So this will, from this to A bar C gives B plus B bar plus A C bar gives B plus B bar C bar C. So the final output will be A XOR C, which is equal to A bar C plus A C.